Hi everyone! Today, we're diving deep into the powerful world of the Uniswap Universal Router. Specifically, we're going to demystify its execute function parameters. This function is incredibly versatile. It lets you combine many different actions into a single Ethereum transaction, saving gas and simplifying complex DeFi strategies. Understanding how its parameters work is absolutely key to mastering this innovation. The execute function is essentially the heart of the universal router, acting like a master controller for all your on-chain interactions. It takes two main parameters, which might look intimidating at first, but are quite logical once you break them down: commands and inputs. Let's start by understanding the commands parameter. This is a single bytes variable. Think of it as a compact list of instructions or a recipe for the router. Each byte within this commands variable represents a specific operation the router can perform. For example, one byte might tell the router to swap exact input, another might instruct it to unwrap WETH, and yet another could mean transfer ETH. The order of these bytes is crucial because it dictates the sequence in which the operations will be executed by the router. The router reads these command bytes one by one, processing each action in the specified order. It's a very efficient way to encode a multi-step process. Now, let's move on to the second parameter: inputs. This parameter is an array of bytes arrays, meaning bytes. So, it's a list where each element is itself a piece of data. Each element in this inputs array directly corresponds to one of the commands specified in the commands parameter. This inputs array provides the specific data needed for each particular command. For instance, if a command byte signifies a swap exact input, the corresponding inputs element would contain all the necessary details for that swap. This includes information like the token addresses involved, the exact amount of tokens to swap, the minimum amount of output tokens expected, and the recipient address. If another command is unwrap WETH, its corresponding inputs element would specify the exact amount of wrapped ether to unwrap into native ETH. The length of the inputs array must always match the number of distinct commands specified in the commands parameter. Each element within the inputs array is typically ABI encoded data, which is a standardized way to package data for smart contracts, ensuring the router can correctly interpret all the necessary details for each operation. The magic truly happens when the router pairs each command byte with its corresponding input data. It processes them sequentially, allowing you to string together highly customizable and complex multi-step operations within a single transaction. You can execute a token swap, then add liquidity, then unwrap WETH, and finally transfer funds, all in one go. This not only saves on gas fees by batching operations but also greatly simplifies the user experience and unlocks advanced DeFi strategies that would otherwise require multiple separate transactions. Understanding this powerful commands and inputs pairing is absolutely crucial. It's the core mechanism that makes the Uniswap Universal Router so incredibly versatile and a game-changer for on-chain interactions. So, there you have it. A clear breakdown of the Uniswap Universal Router's execute function parameters. The commands bytes define the sequence of actions, and the inputs array provides the specific data for each individual action. This powerful combination is what makes the Universal Router such an innovative and essential tool in the DeFi ecosystem. I truly hope this explanation was helpful and made things much clearer for you. Thank you so much for watching today. If you found this video useful, please give it a thumbs up, and don't forget to subscribe for more deep dives into Ethereum and decentralized finance. Hit that notification bell too, so you don't miss any future content.